Hello friends, my name is Bkk Kolhapure. In earlier video we have seen about the centroid. Centroid is a point where the whole area of the body will be acting. We have seen some of the centroids of the regular figures what we are using. For example, if I take a square or rectangle, the centroid is at the center. If I take a circle, the centroid is at the center. If I take a triangle, the centroid of the distance of the triangle from the base is h by 3 if h is the height of the triangle. We have seen in case of semicircle, the distance of the centroid of the semicircle from the diameter is 0.424 r. These are some of the figures what we have used, and we have seen some problems. We will see some other types of problem in this video. For example, if I take up a figure like this, if you see to this figure, you find there are three simple figures. One is a triangle, another you see a rectangle, and third you see a quarter circle. Now my aim is I should form such a shaded area by using these three figures. So we have got a triangle with us, we have got a rectangle with us, and we have got a quarter circle with us. So making combination of these two, I want a shaded portion. So what I will do, for this rectangle, I will add this triangle. We get body. From this body, we will cut out a quarter circle. So here, we call these type of figures as punched out figure, because we are punching some figures from the whole figure. So we call it as punched out figure or cut out figures. So today we will see examples on such punched out or cut out. Some parts, some areas will be added and some areas will be deducted, so that you can finally find out the centroid of a given figure. We shall begin with a simple problem on such cut out figures. Suppose if I take up a figure like this, I want the centroid of this shaded or hatched area. Now here suppose the radius of this quarter circle is say 40 mm, and this width, if I take it as 60 mm, and this height of a triangle, if I take it as 30 mm, you are required to locate the centroid of this shaded area. So if you see to the figure, we find three figures here. One is a rectangle, second is a triangle, and third is a quarter circle. To form the figure, what I will do is, to this rectangle I will add this triangle. From this I am going to punch out or deduct the quarter circle. So this will be our required hatched area. So let us first consider the reference axis. So as you know, the bottommost point and the leftmost point will be the reference axis for the given figure. First step, reference axis. Second, we will divide the figure into the regular figures. We will take up this rectangle. If the rectangle is at the center, I will call it as G1. Then I will take the triangle. Centroid of the triangle is somewhere here, G2. From these two, we will punch out this quarter circle, G3. So one by one we will consider them. So for this, it is unsymmetrical about both x and y axis. We will have to find out both x bar as sigma ax by sigma a, and we will have to find out y bar by using sigma ay by sigma a. So let us draw the table for this component. Then next what we need is the area A mm square. Then we'll go for distance of centroid from 1 1. So whenever we measure from 1 1, the distance will be mm. Then we'll go for distance of centroid from 2 2. So we'll call it as x. So whatever distance I measure from 2 2 will be the x distance. So once you know these two, then we'll go for AY and AX. This is a table having 6 columns. We'll begin with G1. G1 is this rectangle. And what is the size of the rectangle? 60 mm by this height. This height is nothing but the radius of the quarter circle. So it is 60 by 40. 2400. This is the area. We know the center of the rectangle is at the center. I need the distance of centroid from 1 1. Total height is 40. Half of that will be 20. So 40 by 2 is equal to 20. We need the distance of the centroid from 2 2. I need this distance. We know it is at the center. This total distance is 60. Half of that will be 30. So this distance will be 60 by 2 is equal to 30. You know A, you know Y. If you multiply that, you get 48000. You know A and you know X. If you multiply them, you get this as 72000. To this we are going to add G2. What is G2? G2 is a triangle. What is area of triangle? Half into base into height. So half into this is a base which is equal to 60 mm. And height of the triangle is 30 mm. So this will be equal to 900 mm square. We know the distance of the centroid of the triangle I want from here. That is, it's from the line. From the line is nothing but from the base. And we know the distance of the centroid is 1/3 of the height from the base. But I want the distance of this from here, 1 1. So what will be the distance? So up to here it is 40. Plus this distance is h by 3, where h is this height. So 30 by 3 plus 40. So it will be 40 plus 30 by 3. So this will be equal to 50 mm. Now I want the distance of the centroid from here, this distance. We are measuring the distance from the apex. We know the distance of the centroid from the apex is 2/3 of height. Now what is the height? What the direction in which we are moving will become the height. So this height is nothing but 60 mm. So this distance will be 2/3 of 60. If you measure from the line, this is 1/3 h by 3, but I am measuring from the apex, so this should be 2/3 of the height, and the height in this direction is 60. See, when I was going like this, the height was 30 in this direction. When I am going like this, the height of the triangle will be 60. So this distance will be 2/3 of 60. So this will be equal to 40 mm. So if I multiply this 4000, and if I multiply A and X, you get 36000. So what I have done? To a rectangle, I have added the triangle. Adding is over. So what I will do? I draw a line here, almost a double line. So then we will go for deduct. What we are going to deduct is G3. What is G3? G3 is a quarter circle. Whenever you come across circle, write the radius. Radius of this is 40. Radius is 40. So area of quarter circle, pi r square divided by 4. So this will be pi into 40 square divided by 4. So you get area is 1256.6. Now we know the distance of the centroid of a quarter circle from the diameter is 0.424 r. Now this is the centroid. I need this distance, and this 1 1 and diameter are coinciding. So this distance will be 0.424 r. Similarly, the distance of the centroid from 2 2, it is again from the diameter only. So this distance will be also equal to 0.422 r, 0.424 r. So this is 0.424 into R is 40. So this distance will be equal to 25.44. Now this distance is also 0.424 into R. So this will be again 25.44. Now if you multiply A and Y, you get 31967.9. This will also remain same, 31967.9. Nothing to be deducted, so I'll draw a line here. Then I'll go for area. So this net area will be equal to this area plus this area minus this area, because it is deduction. So if you deduct it, the area will be 2043.4. Likewise, I want sigma AY. So sigma AY will be this plus this minus this. So if you get this, you get 61032.1. Similarly, if I want sigma AX, it will be equal to this plus this minus this. So this value you get it as 76032.1. So once you find out this value, you can easily calculate x bar is equal to sigma AX by sigma A. So here sigma AX, be careful, 76032.1 divided by sigma A is a net area, 2043.4. If you simplify this, you get x bar is equal to 37.21 mm. On same lines, if you go for y bar is sigma AY by sigma A. So sigma AY is this column, 61032.1 divided by area is 2043.4. If you simplify this, you get y bar is equal to 29.87. So the coordinates of the centroid of this figure are x bar and y bar. So x bar is here 37.21 mm and y bar is 29.87. So this is how you will have to look at the centroid of punched out area. We'll take up another example to again find out the centroid of the shaded area. Again, this is a punched out type of figure. Now I want to look at the centroid of this shaded area. So you see various figures are here. So let us note down the dimension. This distance is 8 meters. This radius is 4 meters. This distance is 4 meters. And this distance will be 8 meters. So this distance, if I take it as 3 meters. Suppose if I take this total height as 12 meters. Now here the different figures what we see is, one is a square or rectangle, another figure we see is a triangle, third figure we see is a quarter circle, and fourth figure what we see is a semicircle. So you should add and subtract in such a way that you get the required figure. So what I'll do, to this rectangle I'll add this triangle. So I get a body. From this I'll punch out a quarter circle, and I'll punch out a semicircle, and I'll punch out a quarter circle. So this is resembling our shaded area. 2 adding, 2 subtracting. Many options will be there for you to find out this hashed area. So what I am taking here is, it's a rectangle. Let the centroid of the rectangle be G1. Then to that I am adding this triangle. Let the centroid of the triangle be G2. From that I'll punch out this G3 semicircle. I'll punch out a quarter circle. So 2 addition, 2 subtraction. This is one possibility. Another possibility is I'll take a big rectangle. From that I'll punch out a quarter circle. From that I'll punch out a semicircle. From that I'll punch out a triangle. Only one rectangle. You can punch out all the 3. So there will be different options. You have to choose a suitable option. We will go with this option of 2 adding and 2 subtracting. So for that again we need a table. Component, area, we need distance of the centroid from 1, 1. So this will be mm. Then distance of the centroid from 2, 2. Suppose if I take this as 1, 1 reference axis, this as 2, 2 reference axis, then the distance from 2, 2 will be xmm. So once you know these two, you can find out AY and AX. Again 6 columns here we are using. So I will begin with G1. G1 is a rectangle or square, whatever it is. So what will be the size? 8 plus 4, 12. And this is 12. So this will be 12 by 12 is equal to 144. We know for a rectangle the centroid is at the center. So the distance from 1, 1, this height. What is the total height? 12. Half of that will be 6. So this will be 12 by 2 is equal to 6 mm. Again I need the distance of the centroid from 2, 2. So total width of the rectangle is 6 plus 4, 12. Half of that will be 6. So 12 by 6, 2 is equal to 6 mm. You know A, you know Y. If you multiply this, 864, 864. To this I'll add a triangle. What is the size of the triangle? Area of triangle is half into base into height. Half into 3 into height of the triangle is 12 meters. 12. So this will be equal to 18. 18. Now here, this is the centroid of a triangle. I need the distance of the centroid from 1, 1. 1, 1 and base are coinciding. So the distance of the centroid from the base is 1/3 of the height. And how much is the height here? 12. So this distance will be 12 by 3 is equal to 4 meters. Now next is, I want the distance of the centroid from 2, 2. Now if you see to this distance, it is from the line, means from the base. From whenever it is from the line or base, the height of the centroid is 1/3 of the height. See, I am going like this. I need this distance. Then in that case, what will be the height of the triangle? 3 meters. So this will be 3 by 3, 1/3 of 3 plus this distance from 2 to. So the total distance will be 12 meters plus 3 by 3. So this will be 12 plus 3 by 3 is equal to 13. So if you multiply this, you get this as 72 and this you get it as 234. So we have added the two figures. Now you will go for deduction. Draw a double line whenever you are deducting. So from this I am going to deduct G3. What is G3? It is a semicircle whose radius is, how much is the radius? This 8 is the diameter. So radius will be 4 meters. And area of semicircle is pi r square divided by 2. So if you simplify this, you get 25.13. Now the distance of a centroid of a semicircle from the diameter is 0.424 r. Means if this is a diameter, this distance is known to you as 0.424 r. But distance and 1 are coinciding, so this distance will be directly 0.424 into r is 4 meters. If you simplify this, you get 1.7. 3.39. So this is the distance of the centroid. Now I need the distance of the centroid from 2 to. I need this distance. One thing is sure, if this is 8, this is your radius 4 plus this distance 4. So what will be the distance of the centroid from 2 to? It will be 4 plus the radius here. So when you go from the diameter, it is 0.424 r. But in other direction, it will be the radius. So this will be 4 plus 4 will be the distance of the centroid from 2 to. So this will be equal to 8 meters. If you multiply them, you get 85.2 and 201. Likewise, we will go for G4. G4 is a quarter circle whose radius is 4. Please don't make half of that. The radius of the quarter circle remains as 4 only. So here radius area of quarter circle will be pi r square divided by 4. So if you simplify this, you get 12.57. Now I need the distance of the centroid from 1, 1. What we know is the distance of the centroid of the quarter circle from both the diameters, it will be 0.424 r. I know this property, but I want this distance. So what to do? From here you first go up to the diameter. From here to here it is 12. Then you minus 0.424 r. So first go up to the diameter, then deduct it by 0.424 r, so that I will be getting this distance. Is this clear? So go up to diameter 12 minus 0.424 r. So this will be equal to 12 minus 0.424 into r is 4 meters. So if we simplify this, it will be 10.3. Now I want the distance of the centroid from 2 to. It happens from the diameter. So this distance is directly 0.424 r. And r is a 4. So you get this distance is equal to 1.7 meters. Now if you multiply the value, you get this as 129.5 and you get this value as 21.4. Now nothing to be deducted, everything is over. So now we will go for sigma A. So this plus this minus this minus this. So this will be equal to 124.3. Likewise sigma AY. This plus this minus this minus this. So you get a value of 721.3. Likewise sigma AX. This plus this minus this minus this. So you get a value of 875.6. So you want to find out x bar. X bar is equal to sigma AX by sigma A. So that is 875.6 divided by net area is 124.3. You get the value of x bar is equal to 7.05 mm. Likewise y bar is equal to sigma AY by sigma A, 723.3 divided by net area is 124.3. So this if you simplify, you get the value as 5.80. Now here the centroid of the shaded area are given by x bar and y bar. So x bar is 7.05 mm or meter, whatever is the unit given, and this is 5.8 meters. So here the values are in meters. So let us write all the values in meters only. Meters. So this is how you have to look at the centroid of a given figure. In all the figures we have seen, we have taken the reference axis 1, 1 and 2, 2 at the bottommost point and leftmost point, so that our whole figure is in the first quadrant. All x bar and y bar will be positive. Right? This is today's video. Kindly subscribe for the new videos. Press the bell icon for notifications. Please go to the comment box for any questions. Thank you.